This video will establish two of several conclusions that can be reached after reading The Looming Energy Crisis: Are Blackouts Inevitable? We will establish that wind and solar are unsuitable for use in our electric grid. The first conclusion is that wind and solar are unfit for use in reserve margins. The second conclusion is that wind and solar cannot replace fossil fuels. And finally, wind and solar are expensive, but this will be covered in a separate video. This insert explains the meaning of reserve margins. It shows a typical demand curve for a day. The reserve should be established using the highest peak demand on record. Extra capacity is added to ensure there will be enough generating capacity to meet demand if it exceeds the prior peak or if generating equipment fails. Reserve margins are set to ensure reliability and to prevent blackouts. In this instance, the extra capacity provided a 15% reserve margin. This chart was taken from a report issued by ERCOT in December of 2020, just a few months ago. ERCOT manages the Texas electric grid. A portion of the chart has been enlarged for readability. The chart shows that the reserve margin in 2021 was 15.5%. But ERCOT was relying on wind and solar as part of its reserve margin. The actual reserve was nearly zero because there is a 100% certainty that wind and solar will stop generating electricity when there are severe weather conditions. Only base load power can supply electricity 24/7, 365 days a year. Base load power includes coal, nuclear, and natural gas combined cycle power plants, but not wind and solar. This slide, taken from an earlier report, shows that the ERCOT reserve margin, when only using baseload power, was 6% in 2019. Again, baseload power refers to coal, nuclear, and natural gas combined cycle power plants. The purpose of the chart when it was published was to show the need for baseload power. Note that, historically, reserve margins, the dotted purple line, had been nearly 14%. The chart then shows that the reserve margin, using only baseload power in 2020, was expected to be only 3.5%. And, most tellingly, the reserve margin in 2021 was forecast to be essentially zero. Beyond 2021, the reserve margins were forecast to be negative. Referring to the recent events in Texas, this graph shows how much electricity was generated during the period between February 4th and February 16th. The first thing to note is that the dotted line reflects the available generating capacity when the peak demand occurred. The next thing to note is that the available capacity would have been nearly 10,000 megawatts greater, as shown by the solid black line, if the reserve margin had been kept at the historic 14% level, using only baseload power. With that additional reserve capacity, there could have been failures of coal, natural gas, or nuclear power plants as great as the additional capacity without causing blackouts. Blackouts would have been much less severe if the additional 10,000 megawatts of reserve capacity using baseload power had been installed. It's important to note that electricity from wind and solar, shown in green and yellow, fell dramatically on February 9th and provided very little electricity for 6 days. Wind and solar should not have been relied on to contribute to reserve capacity, since they only generated token amounts of electricity during the 6-day period. The failure of renewables in Texas was not unique. This chart from New England showed that there was a 12-day period during which solar power supplied only token amounts of electricity. The light green lines show the expected output from PV solar, while the dark green lines shows the actual output. In Texas, there were 6 days when wind couldn't provide more than token amounts of electricity, while in New England, there were 12 days where solar was virtually unavailable. If storage had been relied on to supply electricity when wind and solar were unavailable, storage would have had to supply enough electricity to meet demand for over 6 days in Texas and over 12 days in New England. While both these events were in the winter, events in the summer could also result in the inability of wind and solar to provide electricity for several days. The most obvious of these would be hurricanes. If wind and solar couldn't produce electricity for several days, it would require batteries as backup, with sufficient capacity to store enough electricity to meet demand for several days, possibly weeks. The largest battery storage built thus far can only store electricity for a few hours, not for days on end. It's virtually impossible to create enough battery storage to meet demand in any grid or region for days on end. Even if it were possible, the cost would almost equal our nation's total national debt, and half of that cost would have to be replaced every 10 years or so. Two of the conclusions we can reach from reading The Looming Energy Crisis, Are Blackouts Inevitable?, are that wind and solar must not be used in reserve margins, and that wind and solar cannot replace fossil fuels. For more information, read The Looming Energy Crisis, Are Blackouts Inevitable?